Hello, all my dear students. I welcome you all to Chakru Academy Just a Minute series. In this series, every minute of your time will help you enhance your board exam concepts and scores. In the last session, if you remember, we discussed all the theory connected with moving coil galvanometer. In today's session, we will discuss some previous year MCQs asked from this topic. As you can see on the screen, the first question is, the coil of a moving coil galvanometer is wound over a metal frame in order to reduce hysteresis, increase sensitivity, increase moment of inertia, and provide electromagnetic damping. If you remember, there is a soft iron core placed between two strong magnetic poles, and on that soft iron core, there was a coil which was wound over it. What was the advantage of that? When you wound a coil over it, when you increase the number of turns, the torque produced will also increase. And when the torque increases, the sensitivity of the galvanometer hence increases. So the answer will be which option? Option B. Very simple question. It will hardly take 10-15 seconds to quickly answer this. Let's move to the next question. Okay, students, let's discuss the next question. Next question is basically assertion reason. As you can see on the screen, the assertion says that on increasing the current sensitivity of a galvanometer by increasing the number of turns may not necessarily increase its voltage sensitivity. What is the reason given? The resistance of the coil of the galvanometer increases when you increase the number of. Let's understand this in a very simple way. As you know that current sensitivity is directly proportional to the number of turns of the coil. So when you increase the number of turns, current sensitivity will increase. And what is the relation between voltage sensitivity and current sensitivity? Is by R. So due to the number of turns being increased, current sensitivity is increasing. But on the same side, when you're increasing the number of turns, the length of the coil, right, is also increasing. When length increases, resistance will also increase. So when number of turns increases, resistance of the coil will also increase. So it is not necessarily true that when current sensitivity increase, voltage sensitivity also has to increase, because this denominator is increasing, which will decrease this. So you need to keep a track of this factor also, that when N increases, length of the coil increases, therefore R will also increase. So our assertion is true, and the reason is perfectly explaining it. So what should be the option? Option A. So let's move to the next question now. Now let's discuss the next assertion reason. As you can see on the screen, the assertion is to increase the range of ammeter, we should connect a suitable high resistance in series to it. The ammeter with the increased range should have high resistance. If you focus on the assertion, they are telling that for increasing the range of the ammeter, you need to connect a suitable high resistance in series to it. It's perfectly wrong. To increase the range of ammeter, we need to connect a small resistor in parallel, which is called shunt resistance. The assertion is perfectly wrong. Now, if you see reason, ammeter with increased range should have high resistance. Ammeter with high range should have a very, very small resistance in parallel. So both assertion and reason are false. So what should be the answer? Option D. Very simple assertion reason. Now let's take one more question, the last question from this topic. Okay, let's discuss one more question. As you can see that the current sensitivity of the galvanometer increases by 20%. If its resistance also increased by 25%, what will be the change in the voltage sensitivity? Very interesting question. Let's solve it. So current sensitivity increases by how much percent? 20. So new current sensitivity will be how much? 1.2 times of original. Simultaneously, resistance also increased by 25%. So new resistance will be equal to 1.25 times of original resistance. As you know, the relation between voltage sensitivity and current sensitivity is Vs equal to Is by, correct? So what will be the new voltage sensitivity? Vs dash will be equal to Is dash by R dash. Substitute the values. 1.2 divided by 1.25 R. So what is Is by R? Is by R is basically your Vs. Now, you have the new voltage sensitivity. You want to find out how much change will happen. How will you find the change? Final minus initial divided by initial into 100. Correct? That's how you find the percentage change. I would like you guys to solve it and write your answers in the comment box that by what percentage it will increase or decrease. Do share this video with your friends and classmates. See you in the next session. Bye guys.